Hey, let's use some partial derivatives to estimate the value of this function at the point 0.9, 1.1. So as we do this, we want to pick some point, first of all, that's very close to the one that we really care about, the 0.9, 1.1. A good choice in this case is going to be 1, 1. All right, 1 is obviously close to both of these values. So this, as we fill into the formula in a second, is going to be our a and b into the formula. Next, let's go ahead and take some partial derivatives. First, let's do it with respect to x. So looking at our function, we look at each one of the x's and take its derivative. Any y's we see along the way, we treat those as though they're constants. So first of all, the x squared, its derivative is going to be 2x. And then for that second term, we can bring along the minus 4 and the y. The derivative of x is just going to be 1. So we can multiply this by 1 if we so chose. That last term, however, 4y squared, because we're taking the partial derivative with respect to x, we treat that all as though it's a constant, right? We're treating y's in this case as though they're constants, so its derivative is going to be 0. So that's our partial derivative with respect to x. Next, let's figure out our partial derivative with respect to y. So we treat our x's as though they're constants this time around, and y's as though that's our only variable. So our first term, the x squared, we're treating that as a constant, so its derivative is going to be 0. The minus 4xy, well, we can bring along our constants, the negative 4 and the x. Derivative of y is just going to be 1, so multiplied by 1. All right, and then that last term, we can use the power rule on that, bring the 2 down in front, multiply it by the 4, get 8, reduce the exponent by 1, and it'll be y to the first power. Next, let's go ahead and figure out what is the partial derivative evaluated at 1, 1, our values for a and b. So, partial derivative of the function with respect to x evaluated at 1, 1 is going to be when we replace the x with a 1, replace the y with a 1. This will work out to 2 minus 4, which is negative 2. Finally, before we fill in to get our estimation, let's do the partial derivative with respect to y evaluated at 1, 1. So that'll be negative 4 times 1 plus 8 times 1, or negative 4 plus 8 works out to be positive 4. All right, so our formula now for estimating this value is going to be f of xy is approximately, well, f of ab. We haven't figured that out yet, so that means we're filling into the original function with 1, 1. So f of 1, 1 is going to be 1 squared, replacing the x with a 1, minus 4 times 1 times 1. Each of the x's and y's in that middle term get replaced with 1, plus 4 times 1 squared at the end. So that'll be what? 1 minus 4 plus 4 happenstance works out to be 1 as well. All right, so 1 is going to get filled in for f of ab plus the partial derivative evaluated at 1, 1. The partial derivative with respect to x evaluated at 1, 1 we said worked out to be 2, so I'm going to go ahead and make minus 2. Then we have x minus our value for a was 1. Now the partial derivative with respect to y evaluated at 1, 1 came out to be 4. And then y minus, we said b was also 1. All right, finally, to get our approximation, we wanted to find an estimate when we filled in 0.9 for x and 1.1 for our y. So that's 1 minus 2 times 0.9 minus 1 plus 4 times 1.1 minus 1. So it's going to be 1 minus 2 times negative 1/10 plus 4 times positive 1/10. Just working the operations inside the parentheses first. So 1 plus 2/10, multiplying there, plus 4/10. So that's 1.6. 1 6/10 is the best estimation we can get using our partial derivatives on this problem. Hope this helps out. Good luck.